We are going to study another special function, Laguerre function. Alright, Laguerre function. It is a kind of special function. Special function. Alright. So the differential equation, the differential, the differential equation for Laguerre function is x d square y upon dx square plus 1 minus x dy by dx plus n y is equals to 0. So this is the differential equation. This equation 1. This is the differential equation for Laguerre function. Alright. So this is a differential equation. There must be some solution for this differential equation. So assume that y be the solution for this differential equation. Say r tends to 0 to infinity ar x to the power k plus r. Good. So I had assumed in increasing order k plus r. So just to satisfy this, I need to differentiate y with respect to x, then after second differentiation of y with respect to x. Alright, so this is the say be the solution for above differential equation, above differential differential equation. Alright, so y is equals to this, then dy upon dx is dy upon dx is summation r tends to 0 to infinity, r tends to 0 to infinity, ar coefficient as it is, k plus r x to the power k plus r minus 1. Good. If we differentiate second time, so this will give me d2y upon dx square. This will give me summation r tends to 0 to infinity ar k plus r minus 1 x to the power k plus r minus 2. Alright, substitute this term and y in equation 1. So this will give me first term is x d2 y upon dx square. So here this is summation r tends to 0 to infinity ar k plus r minus 1 r minus 1 x to the power k plus r minus 2. Good. Plus 1 minus x summation r tends to 0 to infinity, this term ar k plus r x to the power k plus r minus 1. Alright, plus and y is our summation r tends to 0 to infinity ar x to the power r is on subscript ar x to the power k plus r is equals to 0. Just multiply x inside, so this will give me summation r tends to 0 to infinity ar k plus r minus 1 x to the power k plus r minus 1. Just we have multiplied x to this term, so this will give me xr minus 1 plus just multiply, so this will give me just multiply 1 inside, so this will give me summation r tends to 0 to infinity ar k plus r x to the power k plus r minus 1. The minus of just multiply with this minus x, so this will give me summation r tends to 0 to infinity ar k plus r x to the power k plus r plus and summation r tends to 0 to infinity k r x to the power k plus r. equals to 0. Now we had assumed our different solution as increasing order. So I can see there are two terms. One term r in x plus r minus 1 power of, another one is x to the power k plus r. So I know this quantity is smaller than this quantity. So just rearrange the equation in increasing order. Rearranging in increasing order. Increasing order. So this will give me summation r tends to 0 to infinity ar. I think these all are same, so I can take this common. So I can see kr x to the power kr minus 1 here, kr minus 1 here. So this will become kr k plus r, kr minus 1, and from here this will give me plus of k plus r multiple of x to the power k plus r minus 1. Then summation sign from this term. Alright, so I just taken the plus sign common. So this will give me summation r tends to 0 to infinity ar. This is negative of k plus r just because of the plus, and x to the power k plus r is equals to 0. Alright, now just reduce these terms. So this will give me summation r tends to 0 to infinity ar. This r is on subscript. Alright, so just take k plus r common, k plus r common. So here we will have k plus r minus 1 plus 1 x to the power k plus r minus 1. Summation r tends to 0 to infinity ar k plus r plus n x to the power k plus r is equals to 0. I can say this is cancelled out. So here left k plus r. So this will give me r tends to 0 to infinity ar. This will k plus r whole square x to the power k plus r minus 1 plus summation r tends to 0 to infinity ar. Here k plus r plus n x to the power k plus r is equals to 0. Alright, now comparing the coefficient in increasing term. So the first term where I can find is k to the power x to the power k minus r. So comparing the coefficient of x to the power k minus 1. Where I can find this one when I put r equals to 0 in first term. R equals to 0 in first term. Alright, so this will give me a0 k square equals to 0. I know a0 can't be 0, so k can take the value of 0. Alright, now coefficient of x to the power k minus k plus r minus 1. Alright, so where I can find, I can see this term is exactly what I want, and here in second term we need to put r equals to r minus 1. Second term, put r equals to r minus 1. So this is as it is. This will give me ar k plus r whole square plus, I say put r equals to r minus 1. This is r minus 1, and the quantity is k plus r minus 1 plus n is equals to 0. So ar becomes minus of kr minus 1 plus n ar minus 1 upon k plus r whole square. Put k equals to 0. So AR is your AR in minus of R minus 1 plus N R square AR minus 1. Alright, so just rearrange this. This will give me AR. Okay, sorry, here is negative. And if I take this to the right side, this looks my negative sign. Alright, so this becomes N minus R minus plus 1. If I multiply negative sign and open, we will give me this quantity upon R squared AR minus 1. Good. Put R equals to 1. So this is A1. A1 will give me, this is 0. This is N upon 1 square A0. Alright. Put R equals to 2. So this is A2. This is N minus 1 2 square A1. A1 can be written in form of A0. So this is N minus 1 upon 1 square 2 square A0. Alright. Now if you remember, so we have all the coefficient A1, A0 and A2 and so on, we can calculate further. Alright. So if you remember, we know we had assumed y at summation r tends to 0 to infinity AR x to the power k plus r. For k equals to 0, where y becomes summation r tends to 0 to infinity AR x to the power r only. Alright, just expand this series. So this will give me y. This is A0 x to the power 0. Alright, plus A1 x to the power 1 plus A2 x to the power 2 plus A3 x to the power 3 plus so on. Alright, something of power 0 is 1. So this is A0 and A1 can be written in form of A0. So this is n upon 1 square A0 x plus of n minus 1 1 square 2 square A2 A0 x2 plus 1. Now I can take A0 common from all these terms. So this will give me 1 plus n upon 1 square x plus n minus 1 upon 1 square dot 2 square is x square plus 1. And this is going to be negative, right? So if we put, if A0 is 1, so this is yx here. So here yx become ln x, which is a Laguerre function. Which becomes here Laguerre's function. Alright. So now yx is now changed into ln x. Ln x. So this is 1. Now the test quantity is 1 n upon 1 square x plus n minus 1 upon 1 square 2 square x square minus so on. Now to sum up this, I know these are on alt or alternative terms. So first they're not negative, then positive, then negative. So this is going to be summation r tends to 0, and in denominator we have 1 square 2 square, then I can say it's factorial r square. Alright, I can write factorial r square. Alright, now in above we can see 0 n 1 minus n minus n minus 1 factorial. So I can write factorial n here and n minus r here, and the rest quantity x. So r can be 10 from 0 to infinity. So this is your ln x. Alright, so If you This is the Laguerre function. All right, just do remember this one. So in upcoming class, we are going to study the generating function for Laguerre function. Thank you.